take a look inside of a computer, there's a lot of different components. One component that really stands out is this huge guy right here. This is the graphics or video card. This is where the GPU or graphics processing unit lives, also known as the visual processing unit. It really stands out, so you must be thinking, well, that's got to be important. But what does it really do? What's its purpose? What is it used for? That's what we're going to be exploring in this video. Now, some gamers out there might be looking at it and saying, oh, that's easy. It makes my games run smoother and look better in HD. And in a sense, they're right, but that's just the tip of the iceberg of what this piece of hardware is really capable of. My name is David, and along with my partner Shaliza, in this video we will be exploring how the GPU works, the history of the GPU, the benefits of a dedicated graphics card versus integrated graphics, as well as what kind of GPUs are out there and how to determine which one is for you. First of all, we need to understand what is a GPU and what is its purpose. Well, a GPU is actually quite similar to the CPU in that they're both printed circuit boards that perform a set of tasks and calculations at amazing speeds. The difference lies in the types of calculations that they perform. The GPU's job is to render images, animation, and video by taking binary data from the CPU, creating a grid of straight lines, filling it in with pixels, adding color, texture, and lighting, and displaying that image to your monitor. It performs these tasks multiple times per second, depending on the refresh rate of your monitor. Many motherboards, as well as a lot of CPUs nowadays, have what's called integrated graphics. This means that they are capable of performing the same types of tasks as a video card, however, not to the same level of efficiency. This is because integrated graphics share a lot of the resources as the rest of the computer, whereas dedicated graphics usually have their own set of resources. More specifically, they usually have their own set of memory. The GPU utilizes memory to store information about each pixel, such as the color or where it's supposed to be located on the screen. It also has the capability of using the memory to store complete images before it's time to render them onto the screen. This is called frame buffer. More memory means support for high quality textures as well as higher resolution monitors. Integrated graphics usually use anywhere from 1 to 5% of a system's memory, depending on the size of the task. And when it comes to 3D rendering or viewing high definition video, this usually doesn't cut it. This is where dedicated graphics comes in. A dedicated graphics card usually comes equipped with heat sinks, fans, as well as dedicated RAM. This RAM connects to the DAC, or digital to analog converter. This translates the image to analog so that it's capable of being viewed on your monitor. Now, these resources not only make it so that dedicated graphics cards perform better, but they also open up resources for the rest of your computer and will boost overall performance of the system. Dedicated graphics cards are usually connected to the motherboard using one of three interfaces: PCI, AGP, or PCIe. PCIe being the newest and most common because it provides the fastest rate of transfer for data between the GPU and the motherboard.
How does one measure the performance of a graphics card? The hardware in a graphics card directly affects its speed. The following hardware specifications are a good way to measure that speed. It can be measured with the size of the memory bus, measured in bits, the amount of available memory, measured in megabytes or gigabytes, the GPU clock speed, the memory clock rate, and the RAM DAC speed, all measured in megahertz. The CPU and the motherboard also affect the GPU's performance, since no matter how fast the graphics card is, it won't be able to make up for a motherboard that delivers its data slowly. The clock speed of the CPU affects how quickly the GPU gets its instructions. So, how long have graphics cards been around for? Most sources would say that it all started in 1981 when IBM created the monochrome display adapter, also known as the monochrome display and print adapter. Far from what we recognize as a graphics card today, and honestly, not powerful enough to even be called a graphics card at the time, the MDA card was actually incapable of producing real graphics. All it did was display 80 columns by 25 lines of text or symbols. Something worth noting was that the original MDA came with a parallel printer port, hence its alternate name, avoiding the need for a separate parallel interface on computers that had an MDA. But where did it go from there? Why did graphics cards go from things that could only display almost only text to monsters that could let you play your games at 60 plus FPS or create beautiful animations with only a small amount of hangups? It's hard to say that the evolution wasn't mostly prompted by gamers, if only because current gamers are the ones who seem to be most in tune to how the graphic card market fluctuates. You could also say they pushed the market, since most, if not all, advertisements for graphics cards directly references gamers in some way. A few notable cards include the Voodoo 1, made in 1996 by 3DFX. The card only accelerated 3D graphics, forcing its users to rely on a separate 2D graphics card if they wanted to do regular day-to-day computing. This was an important card at the time because gamers now had their dedicated card that could keep up with the games of the time, like Doom, Quake, Duke Nukem 3D, etc. In 2006, we got the ATI Radeon HD 5970, probably the best graphics card of its time. At the time, it was called the fastest graphics card in the world and was also very well ventilated, running almost silent. It lost points with a few people because of its hefty price tag, which is $600+, but what it offered made up for it. It set the bar high for the other competitors who just couldn't stand up to what the card had to offer. Nowadays, there are two main manufacturers of graphics cards, AMD and NVIDIA. However, this was not always the case. Different companies would create new and improved graphics processors that would make them the industry leaders, making previous competitors fall off the map as they couldn't keep up. This created a cycle where every few years a different company reigned supreme. This was the case until NVIDIA came around. ATI was able to compete with them, but was never significantly more advanced, so NVIDIA stayed around. NVIDIA was able to keep rapidly innovating, updating their drivers frequently so as to never fall too far behind. AMD then bought ATI, and they stopped producing as quickly, but are now continuing to be innovative and together with NVIDIA are pushing the boundaries of what modern GPUs can do. No new competitor is likely to emerge as AMD and NVIDIA are so far ahead of the game that it would cost a fortune to try and compete. Seeing as there are only two competitive manufacturers of graphics cards today, it's important to analyze what makes them different from each other. They both perform the same tasks, however, the chipsets have a different infrastructure. NVIDIA has 4 cores per block, or CUDA cores, and each of these are identical to each other and perform the exact same functions as its partners, making for very efficient processing. AMD cards use ATI Stream, which are arranged in blocks of 6. 4 are exactly the same. The 5th computes special functions and the 6th computes differently from the other 5, with the added ability to manage the productivity of the other 5. This arrangement of blocks is called the Arithmetic Logic Unit, or ALU. The ALU are arranged into SIMD engines, also known as Single Instruction Multiple Data Engines, with 80 ALUs per SIMD and up to 20 SIMD engines per GPU.
When trying to determine which graphics card you should buy, the first question you should look to answer is, do I need a graphics card at all? Today's integrated graphics, particularly those found in Intel's Core i5 and i7 processor, are more than well equipped enough for your everyday regular web browsing, video streaming, as well as light gaming for games such as League of Legends or even World of Warcraft. Now, if you're looking to do a little bit more with your PC, such as use a second monitor, render HD video, or play the latest and greatest games, you're going to want to start looking at dedicated graphics. The next thing you want to determine is your price range. Are you looking to get the absolute best of the best in terms of performance? That you're looking at $300+ upwards to even $1,000 for the absolute best. Or can you settle for a kind of lower to mid-tier card, in which case you're looking at anywhere from $150 to $300. These tend to be a little bit better in terms of price versus performance, with the sweet spot being at about $200. The next thing that you want to determine is which brand or chipset you want to go with. As mentioned earlier, the two main brands out there today are AMD and NVIDIA. AMD and NVIDIA tend to go back and forth in terms of which is the best price versus performance at the time, as one will lower its price to compete with the other and vice versa. So do some research, find out which one is the best value, and determine if that's the one you want to go with. After you've determined which type of card you want to go with, the next part is choosing a manufacturer. Now, this can be quite intimidating when you're searching online for a graphics card for the first time. Let's say you've decided you want to get a GeForce NVIDIA GTX 970. You search that on a website, and there's literally dozens of different options. How do you choose? What's the difference? Third-party manufacturers such as Asus, Gigabyte, MSI, and Sapphire get their hands on the reference card and then make their own modifications. Usually these modifications decrease the heat, increase the fan speed, increase the clock speed. Typically they're just meant to increase performance somehow. Every manufacturer will make different tweaks, so you'll have to do some research and determine which manufacturer produces the type of card with the modifications that best suit you. When going through this process, it's important to keep in mind the rest of the components in your system. For example, you don't want to get a video card that requires more power from the power supply than your power supply is capable of giving. As well, you want to make sure that the card will fit in your case, as in some cases the cards get very large, upwards of 12 inches, and smaller cases just won't be able to hold them. The next step is just to install your graphics card and enjoy the benefits of amazing frame rate and really fast performance.